So today, in today's session, we will dive into the hypothesis testing topic. It is a fundamental statistical concept. It helps us to draw conclusion about a population based on a sample. See, the inferential statistics talks about using a sample, how you are going to infer about your population. So in the case of hypothesis testing, we are using a sample. With the sample, we are going to draw a conclusion about the population. Okay, as part of this topic, we will delve into the what and why of hypothesis testing, and then the types of hypothesis testing. Followed by that, we will see how we can perform, what are the steps that are involved in hypothesis testing. That we will, we will take a look at it step by step, and then we will look at what is one-tailed and two-tailed and pair-tailed t-test, and then type 1 and type 2 errors are all about. Okay, now let's embark on the journey together. So what is hypothesis testing? What is hypothesis testing? Can someone tell me what is hypothesis testing? So here, the hypothesis is a way to statistically test your educated guess. So a lot of definitions are floating in the internet, right? So hypothesis testing is a statistical test using which we can make inferences about our population parameters using the sampling data. What is parameter? What is statistic? Parameter is your population mean, standard deviation, and so on. In the case of sample, we have sample mean. We call sample mean, sample standard deviation. These things we call it as a statistic. Okay, as part of the hypothesis test, so we are going to we are going to conduct a test to make inference about the population parameters using the sample data. Okay, so using the hypothesis test, or the hypothesis allows us to test a specific claim or assumption about the population. Basically, we want to test the claim made by someone is correct or not. Supposing let's say you want to buy a brand new Mahindra XUV vehicle, or you want to buy MG Hector car, right? This is a XUV vehicle, you want to buy it. You are so fascinated about the design and the outlook of the car, and you are so fascinated, you want to buy that, but you want to check how much mileage it gives. Let's say hypothetically, right? It gives 14 kilometers per liter. This is the mileage it gives. This is what mine or the company, right? The company, the manufacturer says, say, if you buy MG Hector, so you can get 14 kilometers per liter mileage you will get. So as a user, you are doubting about this claim. Okay, the claim made by the man, whether I don't think so it is going to give 14 kilometers per liter within the city with air condition, everything. Okay, so you want to test this. Okay, you want to test whether the statement or claim made by the manufacturer is true or false. Okay, so that one we are going to see. You can call your friends and you can check with them. When you call your friends or known people, and again the go by the feedback also in the social media sites. But when you call your known people, again, nowadays the feedback can also be modified, right? So they can over represent. Okay, they can manipulate that also. But you want to call your known people to check whether it is really giving 14 kilometers per liter, within the city limits. When I use air condition, even with that, it gives me so you randomly called a couple of guys, let's the 15 known people you called, and then you noted down. Okay, all the 15 people, they are using MG Hector, let us assume that way. You call them and then you noted down how much mileage given for each person. That is your sample. Okay, with that sample itself, you cannot decide whether all the 15 people whom you called and then noted down, so you cannot decide based on your sample itself. So you need to make an educated guess, right? So you cannot do everything based on your gut feel or based on your intuition. That's where the tests are coming into picture. Hypothesis testing is a way to statistically test your educated guess. Okay, instead of making the guess randomly, let's make a educated guess using the hypothesis testing. Okay, it's a statistical test. Okay, hypothesis testing is the process of determining whether or not a given hypothesis is true. It is also, it's also called as significant testing. The other name for hypothesis testing is significance testing, but most of them, the popular name used for this kind of test is hypothesis testing. This is a popular term. Okay, so what is the advantage of conducting the hypothesis testing? It gives us the structured way to make the data driven decision and draw a conclusion based on evidence rather than relying on intuition or guesswork. Okay, so the hypothesis testing is used in medicine, importantly medicine and science and business, right? Most of the businesses, they are using it, and even in the case of social sciences, they are using hypothesis testing. Okay, the statistical hypothesis is an assumption about the population parameter. It is an assumption about the population parameter. Okay, we are making assumption here. For example, if somebody says the Mahindra XUV vehicle, it gives me 15 less than 15 kilometer per liter. This is the mileage given by XUV vehicle. Let's assume that way. Okay, XUV vehicle now within the city limits, or you just think that way. Okay, 15 kilometer per liter mileage, is given by XCV. That is what the manufacturer says. We are also simply make an assumption, and we are assuming that, hey, this is going to be the population parameter, which means the mu, hypothesized mean. We are also assuming that on an average, all the XCV vehicle, let's say specific model. Okay, the model A. Let's say model A. XCV Model A, all the cars manufactured in the XCV Model A, it gives us on an average 15 kilometer per liter. This is what we are going to assume it, because that is what the statement or the claim made by the manufacturer. In the advertisement, we are seeing that in the ad they say a 15 kilometer per liter you can get it if you buy Model A in XCV vehicle. So this is what we are going to assume that as a hypothesized mean. Okay, and the hypothesis population mean, hypothesis mean. Okay, so the statistical hypothesis is an assumption about the population. This is a kind of a parameter, right? This is a parameter. So mean is a population mean is called parameter. So we don't know what is the average mileage given by XCV Model A vehicle. But as per the claim made by the manufacturer, we are assuming that we are hypothesizing that the average mean of the population is going to be 15 kilometer per liter. Okay. So, but okay, and then what we are doing is we are proceeding with conducting the test, statistical test. Okay. Once we conduct the statistical test, we decide whether the hypothesis made by, or whether the statement or the claim made by the manufacturer is true or false. Okay, so we are going to conduct the test. Based on the test outcome, we are going to decide whether the statement made by the manufacturer is true or false. Okay, in the case of hypothesis testing, we use the sample data to evaluate a question about the population, because if you go to the manufacturing unit, you cannot go and check the average mileage for each and every car. So you cannot take let's say 1,000 cars, 1,000 vehicles are there, or 100 vehicles are there. You cannot take 100 vehicles for a test drive, and you cannot say, find out, you cannot note down all the 100 vehicles and how much kilometer per liter it gives. You cannot do that. Okay, you cannot do that. So what you are doing is you are relying on some sample data. In the sense, out of the let's 100 cars manufactured in the last 1 week, you take randomly 20 cars. 20 cars you take randomly, and then you do a test drive, and then you check per kilometer, sorry, per liter, how many kilometer it gets. You note it down. Okay, you need a sample data to evaluate a question about your population. So in the case of hypothesis test, okay, it has two opposing statement. One is the null hypothesis, other one is the alternative hypothesis. So this is the one we are hypothesizing. We are simply assuming that, okay, this is the statement made by the or the claim made by the manufacturer. We are going to assume that yes, it is going to give 15 kilometer per liter. The assumption is nothing but your hypothesis. You know, hypothesized mean, because hypothesized mean. Okay, this is what your null hypothesis. Hypothesis, null hypothesis. Look here, the null hypothesis, and the alternative hypothesis is an opposing statement of this one. To say no, you want to test what you want to test. This is what the claim or the statement made by the manufacturer. What do you want to test? I'm interested in checking. No, it cannot be 15 kilometer. It must be less than 15 kilometer. I want to test this one. This is your alternative hypothesis. Okay, this is what your alternative hypothesis. There are different types of hypothesis testing are available. One is the one sample Z test, and the other one is a Z test. And using a single sample, we can conduct either the Z test or T test, or we can use two independent sample, uh, either the Z test or T test. Okay, you can use a single sample, you can use two independent sample, you can use the paired sample t-test, and also you have multiple sample t-test. That is where there is something called ANOVA, analysis of variances, coming into picture. And next one is the non-parametric test. All these are called your parametric test. What is parameter? So we have hypothesized in the previous case, right? We have, this is what your parameter, right? The mean. The hypothesis mean is your parameter. We are testing the sample mean. We are comparing the sample mean with the population mean. Hence, we are comparing the mean. Mean is a parameter, right? Population mean is called parameter. Population standard deviation is also called as a parameter. The sample mean, sample standard deviation is called statistic. We are using a statistic to make an inference about the population parameter. Parameter is nothing but the population mean in this case. So these tests are called your parametric test. Okay, in this case, obviously you need to use a continuous variable. Okay, the mileage is a continuous variable. Mileage can be 15 kilometer, it can be 10 kilometer. In the case of Maruti, it gives 18 or something, I don't know. Okay, 18. So this takes a continuous value or continuous variable, right? And parametric test. There is something called, is there any way, I have one categorical variable, or I have two categorical variable. Is there any way, any test that is available? That is when we have something called non-parametric test, that is called chi-square test. We will discuss, don't worry, when to use what kind of test. We will discuss it as we move further. Don't worry. So here, this is where you should be able to understand when to use what kind of test. So as part of hypothesis testing, for the continuous variable, we use different type of test, and for the discrete variable, we use different test. Okay, so if the variable is continuous, so and also, right, if you want to compare a single group, or comparison of two groups or a single group, to sample, or I meant about this sample here. You want to compare two different sample groups, or you want to compare single sample mean with the population mean. In that kind, if this is true, if this is yes, and if you know the population standard deviation, then you conduct the Z test. Very simple. If the population standard deviation is known, then you conduct Z test. If the population standard deviation I don't know, then you can conduct T test. But majority of the cases, we don't know the population standard deviation. Take the same example. In the case of Mahindra XUV vehicle, what you are doing is an 8-seater vehicle. You are so curious to buy this because you are fascinated by the model and design done by them. So you go and take 20 different cars for a test ride, and you can note it down how much mileage given by each car. Okay, you can do some kind of sampling. You can do sampling Even first of all, you don't know 100 cars, 100 vehicles they manufactured, all the 100 vehicles of the XUV vehicle, the same model, you don't know what is the average mileage, because you cannot go and check each and every car's mileage. Okay, randomly you sample it, and randomly you take, you request them to give test drive for the 20 vehicles. You drive it and then you note it down. In that case, but whatever the statement they made, like 14 kilometer, 15 kilometers per liter, it gives you the mileage. So literally you assume that as a null hypothesis. But can you ask? So let's say, you are asking them. Let's say when they give for, let's say when you go for a test ride, you're asking the how much mileage. They say 15 kilometers per liter it will give within the city limits. But can you ask them what is the standard deviation? Again, the same brand, same model, you manufactured many vehicle. So what is the variation between one vehicle to another vehicle? Obviously, one vehicle to another, there will be mild variation. So what is the Can you ask them the standard deviation? Will look at you up and down, right? So why he's asking standard deviation? First of all, he doesn't know the driver. What is standard deviation and all, right? So you do not know the standard deviation in that kind of situation, then you can go for t-test. Simple. If you know the population standard deviation, go for c-test. If you don't know the population standard deviation, then you can conduct the t-test. Both the z-test and t-test you can conduct with one sample or two independent samples. You can conduct it. You can conduct these tests. Apart from this, yes, mine is a continuous variable. I want to compare more than two groups. So here there is a limitation. If you want to compare two groups, two independent samples, or a single sample, then these tests are available. Again, there is a condition here, right? So if you know the population standard deviation, go ahead and conduct the C-test. If you don't know the population standard deviation, then T-test you need to do it. What if I have more than two groups? That is when this one comes into picture. Then that kind of situation, you want to compare multiple independent samples, more than two independent samples, mean, if you want to compare it, then you need to use a test called ANOVA. ANOVA stands for analysis of variance. Okay, and let's say, if your variable is a discrete type of variable, and if you want to compare multiple groups, then it's a non-parametric test. Then you can use chi-square test. And if you want to compare two R to a number, then you can go for one or two proportion test. So we are going to focus more on the continuous type of the variable, and we'll look at the multiple groups, right? The chi-square test, discrete variable. We'll look at this. And this is not, I'm not going to cover it, because this is the one or more frequently used. If we Let's focus only on this one. Okay, this one probably, when time permits, will cover it later. Okay, now let us start with a simple example to understand the hypothesis testing in a more intuitive way. For example, okay, so now let us explore with this example how we can conduct the hypothesis testing, or how hypothesis testing can be applied to a real world scenario. Let's say in this case, it involves some snacks packaging. Imagine you are a quality manager. Okay, let's say you are a quality manager at a snack manufacturing company. So the company claims that the average weight of the snack packet is, or the snack package is 250 gram. On top of this package, they printed 250 gram. 250 gram. Okay, this is what the the average weight. You can see it. Listen, this is the weight, right? So they say if you buy this packet, you can, if you unpack it, or if you open this packet, you can find 250 gram quantity of the chips or some snack, okay, in it. But as a quality manager, you suspect, the packaging process might not be as consistent as claimed. You're suspecting. During the coffee break, you go to the pantry in your office, and you go and buy the snack packet, Lay's snack packet. You opened it, and you can see that you suspect that it cannot be 250 gram. They filled more air, and hence the packet size seems to be bigger but on top of the packet I could see 250 gram, but once I open it I could see less quantity. You suspect that it cannot be 250 gram. To investigate that, you decide to conduct the hypothesis testing. Very simple. The what is the average quantity of this packet? I said 250 gram. Okay, but you suspect it cannot be 250 gram. You suspect that it is less than 250 gram. So in that kind of situation, right? So look at this. This is your normal distribution. Okay, and here you think you want to conduct the solution your null hypothesis. You are formulating the hypothesis testing. So as part of the sorry, you are as part of the hypothesis testing, the first step is you need to define the null and alternative hypothesis. As part of the null hypothesis, the null hypothesis, you can use this notation H sub 0. So null hypothesis, okay? You can use this notation. And here the average amount of chips in the packets is 250 gram. That is what printed on top of the packet. But when you open it, you suspect that it cannot be 250 gram. The average, the HA is an alternative hypothesis. This is the notation we use it, alternative hypothesis. The alternative hypothesis is an opposing statement of your null hypothesis. Here you define this one, the null hypothesis. The average amount of chips in the packet is not 250 gram, it is less than 250 gram. Remember that if it is less than, that means left tail test. In hypothesis testing itself, we have left tail test, right tail test, and two tail test. So you have the left tail test. So this is the left tail, right? The left tail test you are going to conduct it. Okay, suppose let's say the 250 gram. This is what the claim made by them. It is there somewhere in the middle, right? 250 gram is there in the middle. In the case of normal distribution, the average is there in the middle. Okay, fine. But what you are suspecting is, it cannot be 250 gram or it cannot be more than this. It is less, somewhere it is falling here. Maybe 240 or 230 or 220 or let's say here 210 gram. Okay, gram. As a quality control manager. So as a customer, here I'm talking from the customer point of view, less than. Less than is you want to test less than 250 gram. Less than is on the left side, right? So anything on the left side, it cannot be 250 gram. It could be less than 250 gram. It could be 210 or 200 gram. As a quality control manager, you are very particular about this issue also, because if the packages if the packaging is not done with the correct quantity or the stated quantity, it can lead to customer dissatisfaction. If the variation is very less, then it is fine. Maybe 2 gram, 3 gram, 5 gram, or up to 10 gram, it is fine. Okay. But if the variation is too high, do you think you are okay with that? You are okay with that, right? So, in this case, what you do is, since it is a less than sign that we are using it, it is a left tail test. Okay. So what the red color tells here, this is called your rejection region. Rejection region. This is what your rejection region area. Rejection region area. The red colored one is your rejection region area. The yellow colored is non-rejection region area. Area. Fine. So in this case, let us say what you are doing is you take randomly, you sample randomly 15 packs. Okay, 5 into 3, 15 packs. In your sample, you have 15 packs are there. You randomly sampled 15 packs. You bought it from different shops, right? In different, at least, this is your. Okay, here 235 grams. Sorry, I should not have tried. Let's say 235 grams. So you sample this, you open all these 15 packets and then pour it in a bowl, and then you check the weight, average, right? So, and then what you do, see, you have, what is the weight of this one? This is 250 gram is there. And here 245 gram is there. Likewise, each and every pack's quantity you have noted down. Since you have 15 packets quantity in your hand, like 250 plus 250, 240, you can find out the average for the 15. So in the denominator 15, And what is this pack's weight? 250 plus 245 plus 240 is there, and somewhere 248 is there. You add all the 15 packs weight in terms of grams and then divide it by 15. This is the one gives you an average. Let's assume that the sample average in this case 235 gram. The sample average in this case 235 gram. Let's assume that way. So will you be okay with that? But whatever they displayed, right, is 250 gram. And but when you randomly sampled 15 packs by buying it from different shops or so, okay, and then you opened it and then you weighed it, and then the sample, when you take the average of all these 15 packets quantity, you get 235 gram. There are two scenarios here. In scenario one, the average amount of chips in this 15 packets is, let's assume that 220 gram is there. Are you okay with that? There is another scenario where the average amount of snack in these 15 packets is 260 gram. Which one are you okay with this? If it is 220 gram, you're not okay with that, right? Because it is whatever they mention is 250 gram, it is too low. Okay, so it's too low, it is not acceptable. But if they fill it anything more than, if they give anything more than this, do you make any complaint? You keep quiet, you'll be happy. You will never complain, right? Or people will never complain. If anything less than 250 gram, then they will complain. Again, if it is way less, then they'll be completely unsatisfied. They are not at all happy. They raise their concern. Okay, as per this sample, you are getting 235 gram. So is that okay? Is it somewhat closer to, it's somewhat closer to 50 gram? Is it okay for you as a customer? Are you okay with that? If you are a very generous guy, you are maybe okay with that. Okay, or if you are a very stringent guy, right? So you might think, no, even if it is a 1 gram less, I'm not going to accept this one. Okay, so in this case, if I go back here, 250 gram, how much you can tolerate? If there is a variation with respect to the quantity in each packet, when you see it, right, let's say you are a generous person, you are, even if it is up to 40 gram less, you are okay with that. Anything less than to 10 gram, you are going to reject it. That one will fall in the rejection region area. Since in the alternative hypothesis you want test less than 250 gram, it is a left tail test, because the rejection region will be there in your left side. The red colored one, the one is your rejection region area. If anything less than this one, so you need to define some cutoff point here to 10 in this case. Okay, let's say I ran a survey and couple of right, ran a survey, they are okay with the 210 gram. Okay, up to, or let's say 230. Okay, 230. Let's make it let's little bit bigger. 248 and 244 and 240 and let's 24. This also 238 gram. Up to 238 gram, they are okay. So that is falling in the non-rejection region area. And but anything less than 242, you are going to reject the null hypothesis. You are going to reject the null hypothesis, and then you are going to conclude that the average amount of chips in the packet is less than 250 gram. But up to 230, 242, you are okay. Now the question is, how do we decide this one? Okay, we have something called critical region. We need to determine the critical region, but critical region is the conventional, the older way of determining this one. Now we use p-value. We have something called p-value. Fine, anyhow, we'll discuss this later. Okay, if any, you just remember that instead of, so this one is kind of a critical region, or based on the p-value we are going to reject it. But for you people to understand, I'm using some number here, 242 gram. If any, up to 252 gram, if I have it in each packet, I'm fine with that. Okay, but anything less than that, I'm not going to accept it. I'm going to reject the null hypothesis. I'm going to say this one. Okay, This is fine. Okay. And let's say we have something else called the right tail test. So 260 gram is there. So this is your right tail test. Your the as per the claim, right? We can see the 250 gram on an average, each packet will contain the snacks in it. Good. So, but in this case, the second scenario too, when you unpacked everything and you measured everything, and then your X bar, the average mean comes closer to 260 gram. It is more than what they stated. They are giving more than what they state. So let's say 260 is somewhat, it falls here, 260 gram. You're happy with that. You are happy, but so as a customer, you're happy. But as a quality manager, you think, let's say you are a quality manager. You think you are happy with this? Per pack, if this fills more quantity than what we stated, it is going to cause a loss to my revenue, isn't it? So overfilling is also a problem. Underfilling is also a problem. Okay. So overfilling leads to loss in revenue. Underfilling leads to damage in reputation. Customer will say these guys will specify 250 gram, but when you unpack it, it will not be there, man. It will be 200 gram or 220 gram or 240 gram. Okay. So even if it falls, let's 255 gram in excess or 260 gram, up to 260 gram, you are okay with that as a quality manager, because you know very well, already, you are in the current quarter, you did not make good money. You cannot afford to buy a new machines to replace the existing one. So you do some kind of analysis. You weigh the pros and cons, and then you are okay even if it fills little more, like 10 gram in excess in each packet, fine. But anything more than that, we cannot afford. You put it in the rejection region area. You are going to reject the null hypothesis and saying that it is not filling correctly. Okay, I'm going to reject the null hypothesis that on an average, each packet does not contain 250 gram. It contains more than 260 gram. In this case, the alternative hypothesis, what you want to test is whether it is filling more than 250 gram. This is what you suspect as a quality manager. But in reality, as a quality manager, okay, you are interested in conducting the two tail test. As a customer, you are interested in the less than, right? If it is anything less than the stated quantity, I'm not going to accept. I'm going to reject the null. But again, there will be some variations between one pack to another pack. But even if there is a variation, I'm okay. I have some tolerance limit. If it is less than up to 250 gram, each packet, contains the quantity, right? Then it is fine with that. Again, there is something called tolerance here. Okay, anything less than 240, I'm going to reject it. Anything greater than 260, I'm going to reject the null hypothesis as a quality manager. As a quality manager, I have to conduct two tail test. It should not be very less. Okay, underfilling should not accepted. Overfilling is also not accepted. Okay, in that kind of situation, overfilling leads to loss to the revenue. Underfilling leads to loss of reputation. It damages the reputation of the company. Again, depends on the scenario. Okay, you need to decide which test you need to conduct. The simple from the customer point of view, you say, hey, it is less than this one, I cannot afford. Okay, so I cannot afford. The right test is, again, it is kind of the quality person. So, or can someone give me any example for the right tail test? When we can conduct the right tail test? As a quality manager, you are very particular about two tail test, because it should not overfill, it should not underfill. Okay, and as a customer, you are very particular less than sin. So when give me some example for right tail test. When are you going to be having a concern that if your thing is more than the stated one, when will you have some concern about that? Give me a scenario. You don't conduct right tail test at all. Okay. No, 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 no. It is not like that. See, for example, you have developed a mobile app, something like Swiggy or food related app. Okay. You developed a mobile app. If it takes lesser time to load, okay. Let's say the average, let's say you are just tapping that app, you want to launch the app in your mobile phone, you want to order some food, you are just tapping that app. If that takes too longer time, also problem. And let's in the recently customers raised concerns when you conducted a survey why people are not ordering, more people are not ordering using your app because the app takes longer time to process the request or a longer time to launch, something like that. Okay, and recently they made some changes to the application, the app, and then mobile app, and then now they want to conduct a test. Okay, the average load time or average processing time in terms of checking out everything. Okay, if that takes, so in that case, what will happen in the case of checkout? Let's say you want to order two favorite food items. You selected that from a specific hotel, and then you click on the checkout. If it takes too longer, also problem. If it takes too less, you're okay, right? If the app is working pretty faster, you're fine, right? So in that case, you are very particular about the time. If it takes more than let's more than 60 seconds, or if it takes more than 2 minutes, the average is you when you tested it after you made changes to your app and improved the performance of your app. Now you say it may not take more than 60 seconds. There will be variation. It depends on the people's mobile phone. In your mobile phone, you install more app, but still, right, there will be some kind of variation. So you are okay to wait until 2 minutes. Anything more than 2 minutes, you are going to reject the null hypothesis, and you are going to say, hey, this app is taking longer time than what they promise it. So in that kind of situation, right tail test you will be conducting it. If the process takes longer time, in this case, if it takes more time, so in that kind of situation you conduct right tail test. The left tail test you will be conducting it in the case of something, right? The quantity, manufacturing unit, or as a customer. In general, the customers they say, yeah, the it cannot be it cannot be less than, sorry, it cannot be more than or the stated value. In the case of snack packet, right, we have seen it. So if it cannot be 250 gram, it is less than 250 gram. You want to test that, you are interested in conducting the test. What test? Less than 250 gram, because you suspect that. But in this case, the right tail test, you suspect that it cannot be 60 seconds. It will take more than 60 seconds, or let's say more than 2 minutes it takes. You want to conduct the test. So more than 60 seconds you want to test it. So this is the average one, hypothesis estimate. More than 60 seconds, okay, there will be variation. So what is the tolerance limit? Up to 2 minutes you are okay. Anything more than 2 minutes, you are going to reject the null hypothesis. In reality, you lose patience, you go and order it from other food app. So in that kind of situation, even both the cases, left and right tail test is can be conducted by the customers. In the case of right tail test, again depends on the context, depends on the situation or scenario. Okay, and in the case of quality manager, you are very particular about overfilling as well as underfilling. In that kind of situations, you need to conduct two two tail test, or the left and right tail test. You need to do it. Okay. Okay, now let's go ahead and understand. So now you got a fair amount of idea. What is left tail test? What is right tail test? And what is two tail test? What kind of scenario we can conduct the what kind of scenario we can conduct the left tail test, what kind of scenario we can conduct the right tail test, what kind of scenario we can conduct two tail test. You got some fair amount of idea about this. High level, you know the big picture some extent now. The whole idea of the hypothesis testing is you wanted to test whether the statement or the claim made by the manufacturer or the customer is correct or not. Okay. If it is less than left tail test, if it is greater than right tail test, if it is, let's say, as a quality manager, you want to make sure that there is no overfilling, underfilling, that kind of situation, you need to conduct two tail test. So, what are the steps involved in hypothesis testing? First, you need to define the null and alternate hypothesis. Second step is you need to collect the sample data. That's why I have shown you 15 snack packet. You need to open those snack packets and weigh it and then find out the average. And then there is another third step called sample statistic. This will say, there is some formula here. If the value, it will give you some value. If that value is less than the critical region area, right, it will fall in the rejection region area. If it is, greater than the critical region value, in that kind of situation, if it is less than, it will fall in the um, rejection region area. If it is greater than, right, it will fall in the right side rejection region area. Okay. So if it falls in the non-rejection region area, you are not going to reject the null hypothesis. If it is falling in the rejection region, you need to reject or fail to reject. We cannot say I'm going to accept the null hypothesis. Statistic, as per, as a statistician, you need to say fail to reject the null hypothesis, which means you are going to accept the null hypothesis. But accepting the null hypothesis, we are not supposed to use the language in statistics. Fail to reject the null hypothesis. Reject the null hypothesis. Based on the outcome of this value, you will decide whether you are going to reject or not reject. You can say not reject. Okay. So, and then you draw conclusion. So these are the 5 steps. Okay. So now let us take a look at this one. What is null hypothesis? What you assume to be true is your null hypothesis. For example, take the same vehicle example, the XUV vehicle, and whatever they say 15 kilometers per liter it will give, you are going to assume, oh, it should be true. But the alternative hypothesis, what you attempt to test, what you attempt to demonstrate, that is what your alternative hypothesis. Here you are going to test, no, it is not giving, it cannot be 15 kilometer per liter, it should be less than, or you can test more than. But as a customer, you are not, even if it gives more mileage, you don't worry about that, right? So the null hypothesis usually an equal sign. Please remember this. A null hypothesis usually an equal sign, an hypothesis of equality, and the alternative hypothesis is usually an inequality. The alternative hypothesis, remember this is very important. The alternative is you can use less than, you can use greater than, or you can use not equal to. Not equal to is your two-tail test, less than is left-tail test, greater than is your right-tail test. Usually in the null hypothesis, we will be using the equal sign only. Okay. For example, a manufacturer states that the average life of a car battery is 24 months. Write the null and alternative hypothesis. What is the null and alternative hypothesis here? They've given the, so this is the statement they made. Okay. This is, I just say it's a claim, right? So they claim that it gives you 24 months. So what I hypothesize here is, okay, the null hypothesis, 20, it gives me the 24 months if I buy this car battery. So let's say as a quality manager, what you want to test it? What do you want to test it? So what is the alternative hypothesis? All of you please type it in the chat window. What is the alternative hypothesis here? What is the counter claim? What is the counter claim? Simple common sense here. Let's say if I tell you, hey, if you buy the battery from me, our brand of battery will give you 24 months. What kind of counter claim that you make it? Simple common sense. Will you believe whatever I say? You're not equal to. Okay, what about others? Very good. Less than 24 months. And Prem Kumar says, no, I'm talking about, look here, not the months. I'm talking about the equality and inequality. So in the null hypothesis, equality, alternative hypothesis, inequality, it can be less than, greater than. Don't tell me in terms of much. Is this a less than or greater than or not equal to? Which one you want to test it? Let's say as a quality manager, right? You want to test it. Mu is not equal to 24 months. Okay. As a quality, this is a counterclaim. As a quality manager, so you don't want the car battery should get expire less than 24 months, or it should not it should, let's the charging capacity is less than 24 months. You are going to lose the reputation of the customer. Yes, majority if you are correct. Very good, very good. Okay, if it is greater than 24 months, it is fine, right? But you are a smart manufacturer. If it goes more than 24 months, yeah, right. So in that case, every once in 2 years, they will not come back to you. If it lasts for longer duration, you are going to lose your business, right? You just think that, okay? So that as a quality manager, you want to test the two-tailed test. You want to conduct the two-tailed test not equal to 24 months. It's in the assembly line. They manufacture all the batteries. As a quality inspector, you go and check it. How long? Let's say you are use some test, okay? 24 months, and then that is whatever the claim made, you say yes, the hypothesized mean is 24 months, and the counterclaim is it is not equal to 24 months. So the claim is mu is equal to counterclaim is not equal to 24. So how do you use the notation? Claim is your null hypothesis. Zero is h sub 0 is null, right? Null hypothesis. Mu is equal to 24. And H1 or HA. In some cases, they use 1 instead of A. So A is alternative hypothesis, or you can use 1. Okay. 1 is opposing your 0, right? So alternative hypothesis is mu is not equal to. So this is what your null hypothesis, this is what your alternative hypothesis. Simple common sense. It doesn't require, too much of brain. Yes, Prem Kumar, you're correct. Jiva, you are correct. Very good. And how about others? Yeah, Leela, you are correct. And Jay Prashant, not Jay Prashant, Aishu, you are correct. Deepa, you are correct. Sara, you are correct. Shri, very good. So this is how the contribution should be there, so that I can make sure that all of you are contributing here. You don't have to watch my video here. That's what I'm saying. Okay. Next one is a company claims that the on an average the snack packet contain at least 100 gram. At least I'm using it here. So what is the null hypothesis? What is the alternative hypothesis? What is at least tells you. Here I have used the at least. What is the difference between at least and at most? At most, so the training duration will last 3 months. At most. What does it says? Prem Kumar says not less than 100. Okay. Not less than. Okay. Which means you are saying that greater than 100, right? Okay. Very good. Somewhat you are partially you're correct. And okay, how about others? Leela says null hypothesis more than or equal to 100 gram. Very good. Okay, more than or equal to 100 gram. Very good. Fatima says null hypothesis more than or equal to 100 gram. And what about the alternative hypothesis in that case? See, at most, this training program is going to last for 4 months at most. If I say the maximum 4 months, it may be less than or up to 4, less than or equal to, right? Less than or equal to 4 months. If I use at most, if it is at least 100 gram is greater than or equal to, okay, either 4 months, the training program can last at least 4 months. That means it may be 4 months or more than 4 months also. Yeah, less than 100, correct. So this is the one. Okay, so in this case it is little bit different. You might be arguing with me. You said in the null hypothesis most of the time we use the equal sign. That's what I mentioned here, right? So always uses equal sign in the case of h sub 0. Now how you can say this way, right? But there are some cases, importantly, at least when you see the clause or at least clause, then if it is 100 and above, okay, the null hypothesis, this one in this case, and the counterclaim is no, it is less than 100, okay, 100 gram. And if you use the statistical notation, guys, please concentrate here. So this is if you use a statistical notation, the claim is your H sub 0, claim made by the manufacturers H sub 0, because he says, right, the company says 100 gram. We are assuming that, okay, whatever you say, maybe at least here, okay, 100 or more than 100, okay. The counterclaim is less than 100. This is a, little bit, different thing, unique scenario. And next question is the UPS manager. Look here, in this case, more than. It's kind of at most. Sorry, it is not at most. It is more than 6 hours per day. So what is the null and alternative hypothesis? Can someone tell me? The claim is obviously right. It gives me the backup hours, UPS, more than 6. So that is what your claim, right? The counterclaim is no, it is not. It is not 6 hours. It is less than 6 hours, less than or equal to 6 hours, or it can be 6 hours or less than 6 hours. It is not more than 6 hours. I bought the UPS from your company, my relative. So according to them, it was giving just 6 months, 6 hours per day. Sometimes it gives less than 6 hours. It is not more than 6 hours. So to test this, so what kind of notation? So this is the notation that we use it. Okay, and this is the notation. The claim is your null hypothesis. But in this case, I have rewritten it. So claim is greater than 6. Okay. So what mu is less than or equal to 6. And then the opposite of this one. Okay. The counterclaim is mu is greater than 6. Okay. In this case, it will be slightly confusing. Okay. Here the claim is greater. So as per the rule, you are not supposed to have greater than or less than in your hypothesis. Sorry, null hypothesis. It should be an equality, right? Equality sign. Hence used at least no equal sign along with the greater than or equal to, less than or equal to. But here they made the statement more than 6 hours per day. But you cannot say more than or equal to, right? So in that case, what to do is less than or equal to, the opposite one. So equal sign along with the less than is permitted. The same thing you can see it here also. Greater than or equal to, we have used it at least, right? So I know either 100 or more than 100, it is possible. But here I did not use less than or greater than. At least along with the greater than, you need to use equal sign. Okay, that is accepted. There is an exception in this case. Okay, in the case of null, in the case of null hypothesis, most of the time the equal sign only will be there. The equality sign will be there. And alternative hypothesis only, you will be having inequality signs, less than, greater than, not equal to. But there are some exceptions wherein you can have the inequality sign along with the equal. Okay, greater than or equal to, and less than or equal to, it is allowed. Okay, less than or equal to is allowed here. Okay, so here we are assuming that it can give either 6 hours or less than 6 hours. Again, it depends on the context. We want to test whether it is going to give more than 6 hours per day. In that kind of situation, you need to change your null and alternative hypothesis. What you want to test it, what you want to reject it, right? What you want to reject it, that you can put it in your null hypothesis. What you want to test it, that is there in your alternative hypothesis. It is as simple as that. Okay, in this case, what you are saying is null hypothesis more than 6 hours. Okay, alternative hypothesis less than or equal to 6 hours. That is what the claim. But as per the rule, you cannot have greater than or less than in the case of null hypothesis. Okay, you can have greater than or less than, but it should be combined with the less than sign also. Greater than or equal to, less than or. But if you put greater than or equal to, can you put greater than or equal to here? Because here the problem statement provides more than 6 hours. They did not say 6 hours and above, right? So hence you need to rewrite it. This is a tricky question. Don't accept in the interview or the test. It's all pretty straightforward, but understand the rule very clearly. So now you understood the rule. You can have equal sign, sorry, greater than sign, less than sign, but along with that, you need to have the equal sign. It is mandatory. But if I put equal sign here, what will happen? So you are going to misinterpret that. You are making a wrong assumption. Okay. But here, what you're saying here is null hypothesis. What you want to test. In this case, you are very particular what you want to test. Sorry. Okay. In this case, you want to test what you want. In this case, you want to decide what you want. We are interested in testing it out. So great. Okay. What you are saying is, Fatima says less than or equal to 6. Hmm. Okay. Okay. Null hypothesis more than 6 hours. Less than or equal to 6, that is what I mentioned already. But because of the rule, okay, I have, we need to rewrite it. So what this is actually correct. Fatima is, before even I displayed this, she answered correctly. But when you use it in the notation, you need to use it this way, and because the rule, okay, and you need to read it. So here, what I want to test it, I put it in the alternative hypothesis. I want to reject this one, I just put this one. But again, it depends on the statistic value. You decide whether you want to reject, or okay, or you are going to not reject. This is very rarely you will encounter this. Anything is greater than, right, you need to rewrite it something like that. And okay, that is also the reason, right? It is a general practice to use greater than or equal, less than or equal to equal sign. If you find less than or equal to greater than, better you can put equal sign. Okay, so sign the null point. It can also be rewritten as less than or equal to put equal sign. So now they remove that confusion. If it is more than, you need to use less than or equal to. But you want to test, no, it is not. No, it's giving more than 6. So this is what I want to test it. But here, instead of less than or equal, you can put equal sign. Greater than or equal, you can put equal sign. Okay. The type of test to be conducted based on the alternative hypothesis. Correct. What you want to test? Greater than 6. Or you just think that way. So we want to test whether it is really giving more than 6. I want to test it. In that case, obviously less than or equal to 6 here. So here, greater than or equal to or less than 6. Okay, you just put. So you can say, hey, it cannot be 6, or it cannot be 6, or it cannot be more than 6. It must be less than 6. Better you replace the less than or equal to greater than or equal to by equal sign. Now all confusion clear. So the two-tailed test not equal to, you need to use it. Left-tailed test less than, it's a left side test or one-tailed test. Instead of saying one-tailed test, so we can say the left side test or right side test. Okay, it is also called as a two-tailed test. Which one? The not equal is both side. Hence, you need to conduct the right tail test or left tail test. Okay, both you need to conduct it. But whereas here you are very particular about less than the quantity they mentioned or displayed on top of the packet. Okay, so in the null hypothesis, you can use sorry, in the alternative hypothesis, you need to use not equal to, less than, or greater than. In the case of right side, you need to use greater than. This is pretty straightforward. Okay, and the next thing is, okay, now sort of I understood what is left tail test, right tail test, two tail test. You understood so far, and you learned about what is null hypothesis, what is alternative hypothesis, and also we went one step ahead, and then we discussed about in the case of in the case of different scenarios, how we need to define the null and alternative. We discussed. Okay, and also importantly, we discussed in most of the cases null hypothesis. We need to use we will be using equal sign only. The alternative hypothesis we will be using either less than or greater than or not equal. That is what we discussed so far. Okay, the next thing is, so what test needs to be conducted when? Okay, if the population data is normal and if the population standard deviation is known, then you conduct the C-test statistic. In both the case of single sample or two independent sample. Okay, if you don't know the population standard deviation, you will have to conduct the t-test statistic. There is a formula for these two things. It's very simple one. In the case of t-test, the formula is so the z x minus x bar minus mu divided by sigma. And here in this case, what formula that we'll be using it? When in the case of t set, t is equal to x bar minus here mu divided by sample standard deviation. We don't know the population standard deviation, hence we use the sample standard deviation. The first step in the hypothesis testing is you need to define null and alternative test. So I sorry, null and alternative hypothesis. Okay. The second step is you need to collect this sample. You remember I have shown you in the previous slide. We collected 15 snack packets as part of my sample, right? That is your sample. When you have the sample data, obviously you can find out the sample means sample standard deviation. The denominator, in the case of test statistic, t-test statistic, you need to use the sample standard deviation. Since we know the population standard deviation, let's say somebody gives you the population standard deviation, in that kind of situation, you can directly plug in the value here. Okay, the mu and sigma already known. Importantly, when you know the sigma, which is nothing but the standard deviation, population standard, this notation tells us population standard deviation. If you know that, then you can go ahead and conduct z-test statistic. If you don't know this, then you conduct the t-test statistic. Okay, if you don't know the population standard, okay. If the population is not normal, and if the sample size is also or if the sample size is 30 or above, there is another rule here. Okay, z-test statistic. In simple term, if your sample size 30 and above, and also if you know the population standard deviation, then you can go for z-test statistic. Like I said, you cannot ask the Mahindra company, okay, the mileage, how much. So you can ask this question with the Mahindra company. You can ask them what is the average mileage given by this specific vehicle. They say 15 kilometer per hour, but you cannot ask them what is the standard deviation because he doesn't know. When you don't know the population standard deviation, obviously you need to conduct the test status, t-test statistic. This is the one we will be conducting it most of the time because most of the time we don't have access to the population data. Even when the XUV the Mahindra manufacturer, when they say, car manufacturer, when they say the average, see the mileage is 15 liters per liter, we are going to assume that 15 kilometers per liter is going to be a hypothesized average mean. The hypothesized mean. We are going to hypothesize, oh, that is going to be the average mileage given by all the vehicles of Mahindra for that specific model. If you know but you don't know the population standard deviation. So in that kind of situation, you need to conduct the t-test statistic. Okay, and if the sample size is 30 and above, and if you know the population, then you can go for z-test. Okay, you can conduct the you can calculate the z-test statistic. Okay, and next one is these are the standard values. If you I believe all of you must have used the logbook during college time. At the back side of the logbook, you can see the Z distribution table, T distribution table, right? So in that, if you see the values for this one, the lower tail and upper tail, two tail, so these are so for example, usually these are the significance values used. The commonly used significance level is 0.05. You remember in this case, look here, I told you the 250 gram is there here. This is the average. Okay, this is the claim made by the manufacturer. You want to test less than 2. You are saying that no, it cannot be 250 gram. It is too less than 250 gram. You want to blindly, just because you opened your packet, if you find less, that doesn't mean all the packets are having less than 250 gram, isn't it? You need to randomly sample the packets, and then you need to test it. Okay, and let's say if it is less than 250 gram, you are suspecting that, and you are okay up to 250 gram. Okay, anything less than 250 gram, because RR region, you are going to 240 gram. Anything less than 240 gram, you are going to reject the null hypothesis, saying that you're saying that it is not less than 250 gram. You are going to decide, okay, if it is. So this value needs to be determined by the tester or the researcher. Let's say you are going to do the test. You need to decide. You should be knowing that what value, anything less than this value should be rejected. This value, right, is called your critical value or something like that. Okay. You remember in yesterday's session, the confidence level, we discussed about anything, sorry, for a curve, right? The area for the curve is 1 by default. And we discussed something about alpha. Alpha is your significance level, right? So if the alpha value is 0.05, this is the conventionally used value, 0.0. This is a significance. It's also significance level. We'll see this one. This is a commonly used significance level. So this is an additional thing you need to put it in your brain. Okay, that I will discuss it little later. Don't worry. Okay, as part of this test, we are going to conduct a single sample hypothesis Z test. Let's assume that in this case we know the population standard deviation. So in that kind of situation, obviously we need to conduct the Z test because we know the population standard deviation. We are lucky. Okay. So in first of all, what is one sample Z test? Before we conduct the test, first let us understand what exactly one sample Z test. So we know very well, if you know the population mean, sorry, standard deviation, then you can conduct the sample Z test. In the case of Z test, the data must be, whatever the data you have, it must be, or in order to conduct the one sample Z test, the data must meet certain assumption. What are the assumptions? The data must be independent. The data must be independent, and then it should be continuous. The value should be continuous. In your sample, you should have the continuous, it's a continuous variable, okay? And then the next one, normally distributed. The population should be normally distributed. The population standard deviation should be known, you know. So only when you have these things, okay, if your data must meet these assumptions, up to this assumption, this is not an assumption, okay, yeah, it makes an assumption. The population standard is known, and if the population is not, data is normally distributed, and if it is a continuous variable, and if the data are independent, it is not depending on one value, other value, okay. So in that kind of situation, you can go ahead and do the Z test. The Z test is a powerful tool to compare a sample mean to a known or hypothesized population mean. The classic example, mileage. We hypothesized. They did not say, the Mahindra company did not say, this is the average mileage given, 15 kilometers per liter is the average mileage given by all the cars which we manufactured in this specific model. They did not say that is the average. What they say is 15 kilometers per liter. This is the mileage given. We are assuming that. We are assuming that the 15 kilometers per liter is the population mean. Hence, that is called hypothesized population mean. Okay. So, but you need to keep one thing in mind. This test, these one sample Z test, it works only if the data meets these assumptions, the assumptions of normality and independence. If this data, whatever given to you, or if the population doesn't follow these assumptions, the result of your test may not be accurate. The result of the test may not be accurate. That is what they say. Okay, that is what in statistics they say. Okay, now let us go ahead and take a look at. We'll conduct one single sample uh, Z test, hypothesis Z test. So here is a one scenario here. Okay, in this case, let's assume that you are a quality manager. You work for a chocolate manufacturing company, and your company claim that each chocolate bar weighs on an average of 50 grams, but you suspect the packaging process might not be consistent, can lead to variation in the weight of the chocolate bars. And then the standard deviation is 4 grams. They gave you sigma. population standard deviation they gave you, and then average also they given. This is your average of, the now your population mean is 50 grams, then population standard, sorry, your population standard deviation also given. Since you know the population standard deviation, you are good to go ahead and conduct with the Z test, isn't it? You can conduct the Z test. So what is the first step? What is the first step? Can someone tell me what is the first step? As part of conducting the test hypothesis, what are the steps involved? And tell me at least the first step. Tell me the first step. Yes, you are correct. You need to formulate the null and alternative hypothesis. Very good. Okay, what is the second step? What is the second step? Okay, the second step is, let's say this way. Okay, the second step is, so whether you want you want to conduct the left tail test or right tail test. Okay, as part of your null hypothesis, you hypothesize the population mean is 50 gram, that has been given. The alternative is an opposite. In that case, as a quality manager, you are going to say not equal to, you want to conduct the alternative hypothesis. Here I did not write it. The alternative hypothesis, I'm going to write HA. As a quality manager, you want to conduct two-tailed test. So you want to test whether the chocolate bar weighs is less than 50 gram or greater than 50 gram. If it is less than 50 gram, what is going to happen? If it is less than 50 gram, what is going to happen? It leads to customer dissatisfaction. Customer, it is going to damage your reputation. The people will say, here, this brand is always made. They put something, but when you open it and see it will not be exactly 50 gram. It will be very less. So, as a quality manager, it is your responsibility to check whether it is the weight is or whether it is overweight or underweight. Okay, so this is the manual way of conducting the test. But if you do it using any statistical software, including Python, it will not take much time. In a matter of second, you'll be doing one liner. You can do it. Okay, but you need to understand the manual test. Only then you'll be able to understand the underlying principle. As a quality inspector, you are very particular about this one. Okay, what is the next step? What are the next steps? The second step is randomly you need to sample the data. For example, in my sample, I'm sampling 36 chocolate bars, choco bars. Okay, and then let's assume that the average mean. I bought 36 packets. Each packet, the average is 50 grams, right? It comes around like 48 gram, one packet in pack one, and then another pack two is a 44 gram, and our pack two 50 gram is there, and somewhere you have 48 gram. Likewise, 36 packets, right? You unpack it and then you weigh it and then you take the average of it. So each pack, you can see the weight is this much, and you add all the value divided by 36. You see, when you do so, you get 40 8 gram on an average. You can see, or let's say 47 gram is there. Let's assume that way. This is your average mean. Okay, when you add 48 plus 44 plus 50 plus etc., right, up to 36. Okay, 36 packets, weights, each packet weight, you add it and then you have 36, you get let's say 47 gram. Let's assume this way. Okay, and then the standard deviation. So in this case, let's say the standard deviation is 3 gram or something like that. Okay, or 2.5, something like that. Okay, and then the sample. Okay, the next one is, so this is now in step two. We have collected this sample, and then we have calculated this sample mean. And if you, let's say, let's assume that when you find out the sample standard deviation, you get 3 standard deviation, STD 3. Okay, 3 grams. Sorry, I'll just write it here neatly. 3 grams. So this is also 47 gram. This is my sample. Okay, 36 my 36 samples, mean, and then standard deviation 3 gram. Okay. And the next step is we know the population standard deviation. Okay, population standard deviation is known. So we need to conduct the Z test. So so in this case, before we conduct the Z test, in step 3, I'm going to set the significance level, set or define the significance level. Significance level, which is nothing but alpha. I'm going to introduce something new. So far, you might be okay with this one. So next one is a little bit different. You need to ingest this in your brain. There is no way. Okay. So the significance level for the alpha hypothesis test is alpha. Okay, that's the term we use it. Let us assume that alpha equal to 0.05. Guys, you remember I was talking about this one. Let's say in this case, the average is 50 grams. 50 gram. And since we have used the alternative hypothesis not equal to, we want to conduct the two-tailed test. Fine. And in this case, how much variation you are okay to tolerate? Let's say if it is going to be 47 gram, anything less than that, you are going to reject it. Okay. But anything above 55 gram, you are going to reject it. It will fall in the rejection region area. Okay. This is the one, right? I meant, this one, this region. Anything falls within this region, you are not going to reject. You are going to accept the null hypothesis, saying that no. So the whatever the statement or the claim made by the manufacturer is correct. On an average, each packet contains 50 grams weight of the chocobar. Okay, fine. But this one, how much you are going to tolerate? That is what you're going to use alpha. Alpha is coming into that one. Okay. So usually, conventionally, we use the value 0.05 here. Okay, you just keep this one, park this in your brain. Step 4, what we will do is we are going to calculate the test statistic. Calculate test statistic. For the Z test, the formula is x bar by minus mu divided by, sigma divided by square root of n. Previously I mentioned wrongly. Okay, this is the correct formula. Okay, x bar minus mu divided by sigma. So here, can all of you type it in the chat window? What is the x bar here? What is the x bar? All of you please contribute here. Please don't watch your WhatsApp or Instagram. Please focus here. So what is x bar? I already have written it. Please tell me quickly. All of you, please. 47. Yeah, correct. You're correct, right? How about others? See here, nobody is great, nobody is less. Please type it. So look at my screen and tell me what is X bar here. Tell me the value here. All of you, please type it in the chat window. The contribution is very much important. See, once you join a company, you should, if you are working as an individual contributor, it is good. But if you cannot work as a group, then you are gone. Okay. The Yeah. So what is X bar here? 47 I mentioned, right? 47 minus what is mu? What does the population mean? 50 gram. Population mean. Yeah. And sigma, what is the sigma given? How much they've given the standard deviation here? How much did I say? Nobody is concentrating here, guys. If you tell me you are not able to understand, that means you are not. See, you need to note down everything. Look here, Neela, Leela, and Sudha and Swarna, they typed it. Rest of you people are not concentrating here. You need to remember everything here. When you talk to an American in the status call like this, if you don't respond, your life is in deep trouble. Okay. So what is the standard deviation I told you? 5 grams? Did I say 5 grams or 4 grams? Look here, 4 grams, right? I told you 4 grams. Please remember this. Please include your. So what is the sigma population standard is 4 grams divided by square root of what is n here? What is the n here? N equal to 36. Guys, everything I've given here, n equal to 36. Don't be shy, okay? And standard deviation is, this is sample not required because we know the population standard that they've given it 4 and sample size is 36. What is the value here? 47 minus 50 is minus 3 divided by 4 divided by 6. So here minus 3 divided by 0.666 will get it. I'll say minus 3 divided by 0.67 we can say, right? 0.6. What is the value of this one? Can all of you please type it in the chat room to calculate? Can you help me out on this? So minus 3 divided by 0.67. What is this? Minus 3 divided by 0.67 minus 4.47, negative 4.47. So if I divide this value by this, what is the z value I'm getting it? Z is equal to minus 4.47. I'm getting it, right? This is my z value. This is my z value, okay? So using this formula, when I plugged in all the values, very simple. We are able to get the z value. Okay, now let us look at this the image here or the curve here. Okay, so here when you look at here, okay, so I told you the area under the curve is 1 minus alpha. Alpha is the significance level 0.05. 1 minus 0.05, how much? You will get 95.95, right? 1 minus 0 point is, sorry, 1 minus 0 point is 0.95, you'll get it. Okay, divided by 2, because you want to conduct the two-tailed test. You have used the not equal to sign in your alternate hypothesis. Hence, this one will come close to 0.457 or something like that. As part of step 2, we are looking at here. So, in the area under the curve is 1. We already discussed. This is the universal thing, okay? Even if you do PST, this will not change. 1 minus alpha. So alpha is the tolerance level. I told you, right? 47 gram. Anything less than 47, we are going to reject. So, but here we don't use the value as it is. Instead, we use something called alpha, right? So anything, for example, 0.457, right? This is the area. So this is the value you are going to do a lookup directly in our Z distribution table. This is your Z distribution where you can find the 0.47 here, right? Sorry, this is the 0.475. It's not point, this 0.45, sorry, 0.475, yeah, 0.475. 1 minus 1 minus 0.05 will give you 0.95. So that 0.95 divided by 2, because you want to conduct the two-tailed test, you need to divide it by 2, 0.75. Okay, here the area is 0.7, here 0.75. When you look at here 0.475, vertically and horizontally, when you see it here, sorry, exactly, right, 1.9. If you see, so my hand is, trembling here, and here 6, right, 0.06. So at the intersection of 1.9 and 0.06, we can see this value 0.475. If you add these two values, 1.9 plus 0.6, 1.96. Correct? 1.96. This is how, sorry, 1.96. 1.96. 1.96. Okay, that is what your critical region. I told you here at which value, up to which value you are okay to tolerate. Anything less than this, you are going to. So here we are not going to use the value literally. So here, so in this 1.96, we got it, right? And here on the left side, it is minus 1.96. Then right side tail, plus 1.96. What is the z value we got it? Z value is negative 4. So minus 4 is less than minus 1.96. Is this correct? Can someone tell me? Is this correct? Obviously, right? If the negative value is more, right, that means it has a lesser value. If your account balance is negative, that means you have more loan, right? So more the negative value, that means negative credit, right? So the sense the z value is false in the rejection region area. Hence we are rejecting the null hypothesis, and we are going to conclude that whatever, right. So the left side tail test is failed. The right side also, even the case of right side, in that case, right, yeah, right side, it will not come here at all because the negative value, we got the negative value, hence it is falling in this region. So we are going to reject the null hypothesis, stating that because it is falling, so it is falling in the rejection region area. Which one? This value. The Okay, I will write it neatly. This is a little bit mess. See, step one, you are clear. You need to define the null and alternative hypothesis. In step two, you need to take your sample and find out the sample mean. And you need to find out the sample standard deviation. In the case of Z test, you know the population standardization, and this is not required. This step is not required. But anyhow, you can find out. So what is the number of samples? So the sample size, we use n, right? Not a small n equal to 36. 36 packets I used it. But 36 packets, when you take the average, I'm getting 47 gram. Okay, and then standard. You just think that way. And next step is we are going to define the significance. Why we need to use the significance level? Because we cannot use the value as it is. Okay, anything less than this, it is falling in the which one? This is a critical value, right? Something like that we are going to define it with alpha equal to 0. The rejection region area, we are going to define it with alpha value. The conventionally they use this value 0.05. Okay, so okay, how it is going to helpful, we know very well. The total area under the curve is 1 minus alpha is 1 minus alpha is the 0.95. So alpha is 0.5, right? 0.05. So 0.95. Since we are conducting the two-tailed test, so we'll get 0.475. This 0.475, if you do a lookup in the z distribution table, you can find it you can locate it somewhere here, right? And just look above this, what value you have it here. And on the horizontally and vertically, you see at which values intersection. This value you can find it here, 1.9 and 0.06. If you add these two values, 1.96. Okay, and on the left side of the tail, it is going to minus 1.96. On the right side of the tail, it is going to be plus 1.96. So that means you are going to define the cutoff here. This line is the border, something like India, Pakistan. Okay, use the border. Okay, this border is determined with this value, z critical value minus 1.96. Anything less than minus 1.96, that falls in the rejection region. Anything above the 1.96, that is falling in the rejection region area. What do you mean by anything falling in this falling in this rejection? What do you mean by that? Right. So we are going to define the border with this value, plus 1.96 minus 1.96. Right. On the left side, minus 1.96. On the right side. So I'll just write it neatly here. See, this is the one. In the middle, you have 50 gram. And this is what your cutoff. How do you determine the cutoff? Minus 1.96. This one. Okay. So here, not 4.475, where it intersects. What are the intersecting values for this? 1.9 and 0.06. On the left side, because we are conducting the two-tailed test, the 1.96, on the left side, you need to specify minus 1.96. On the right side, we need to put plus 1.96. What is my z-test statistics value? X bar minus mu divided by sigma divided by square root of n. So we got something like minus 4.47. We know what is sample mean. We know what is population mean. We know what is population standard deviation. We know what is the sample size. So just plug in this value. So this is called your z value. If this is called your critical value, I call it critical value. If my z value is less than the critical value, reject x sub 0. That means reject the null hypothesis. If my z value is greater than critical value, then also I'm going to reject the null hypothesis. Otherwise, I'm not going to reject the null hypothesis. For example, had I got something like the z values, let's z values 1 point plus 1.3. 1.3 is not less than negative 1.96. 1.3 is not greater than this. Hence, it is falling in the non-rejection region area. In that case, we fail to reject the null hypothesis. If the z value is less than this critical value, in our case minus 4 point, obviously it is falling in the left side. This is called your RR, rejection region area. It is falling in this region. Which one? This value is falling in this region. Hence, we are going to, because it is less than your minus 1.9, it is following the rejection area. Hence, we are rejecting the null hypothesis. Like so, here in the two test, right here, if it is less than critical value, greater than critical value, also falling in the rejection area. Here, since the negative value, here reject the null hypothesis. Okay, and then we are going to conclude that whatever the statement made by the manufacturer or the manufacturing manager, right, is not true. Okay, so it is less than 50 gram. The packaging process fills less than 50 gram, or each on an average the chocolate bar is not 50 gram, it is less than 50 gram. There is some, so in this case, you believe me or not, I heard from one student, he's working with Ford, Chennai Ford, Tidal Park. Okay, he's a group manager. He told me this one. They conduct the hypothesis test and they will stop the production process itself. They're not going to, if they they're going to reject the null hypothesis, they're not going to continue with the production. They stop the entire production. It is very critical. Okay, it is used in the manufacturing industry. Majority of the manufacturing industry, they conduct the hypothesis test, and also other companies. Medicine, important. Medicine also manufactured. The pharmacy, Pfizer. If you see, Pfizer is one of the leading pharmacy in USA. Okay, so they conduct all kind of tests. So if you know the population standard deviation, then you can go for conducting the z-test. So in this case, we have used a single sample. Hence, it is called single sample z-test because we know the population standard deviation and the sample is single sample. Hence, it's called a single sample hypothesis, single sample hypothesis test. And what are the other things you need to remember? In order to conduct the one sample z-test, what are the prerequisites? The z-test makes an assumption that data must be independent, okay, and it should be continuous. Okay, in this case, the gram, right, 50 gram is a continuous variable. The weight of each bar is a continuous variable. Yes, it is meeting that assumption. Normally distributed. Let us assume that the population is normally distributed, and then population standard deviation we have known. Hence, we have conducted the z-test. If you know the population standard deviation, you can conduct the very good. I can see a lot of people response here. Minus 4.48. Very good, very good, very good, very good, very good. So if you work side by side like this, right, you don't have to